are multicellular. It was one of the characteristics that we talked about. When we look and consider animals and their cells, I have a few questions. Are the cells of an elephant larger than the cells of a mouse? So do we make animals bigger by increasing the size of their cells, or do we do something else? And by the way, are there cells that are huge, the size of a grapefruit? And so if there isn't, what limits cell size? And that's what I'm going to talk about. Now, technically, an ostrich egg, so one of the biggest birds today, we had bigger, and if you went to my New Zealand talk, you learned about the moas, which were even bigger, and their eggs were even bigger. But an ostrich egg is about the size of a cantaloupe, like you might eat the orange flesh cantaloupe. Sweet, I hope, cantaloupe. Technically, that is one egg, but the functional part of the cell is really a small, tiny spot. So technically, it is an egg, but functionally, it functions still as a very small cell. Okay? So when we think of what limits cell size, the first clue has to do with daycares. And some of you may know about a daycare, and you may know that the number of kids that they can have at a daycare is limited by the number of the adults. And that actually has to do with the age of the child. So maybe some of you know if the children are infants, so if they're under the age of 1, then the number of children you can have under the age of 1 is quite limited per adult, trained adults, licensed adults. But if kids are much older, then one adult can handle more. In any case, there's a limit to the number of kids based on the supervisor. Well, if you think about cells, what's the supervisor in my analogy? And if you guessed the nucleus, you would be right. So the nucleus doesn't grow in size. The cells get bigger or smaller, and an individual cell in your body, like a muscle cell, can grow larger or smaller. But the nucleus itself doesn't increase in size. It's the cytoplasm. So one limit of cell size, and here is a very, very large cell. I was just talking about muscles. So this is a skeletal muscle. This is the one that makes your skeleton move, so it allows you to bend your arms and legs and run and do all that good stuff. When we take a look at the skeletal muscle cell, if you know already, perhaps, skeletal muscle cells are the largest by far of all the types of muscle. So we have cardiac and smooth and skeletal muscle. They're also just really, really big cells in our body. Well, how is it that they can be big? Well, how could you have a daycare with a lot of kids? And the answer is you'd have to have a lot of adults. Well, when we take a look at skeletal muscle in our body, they have a lot of nuclei. So that suggests, back to the whole point of this slide, that one limit of cell size is the ratio of the ratio, just like we had a ratio of adults to kids in a daycare, the ratio of one nucleus to the amount of cytoplasm. And we call that the nuclear to cytoplasmic ratio. So to get really, really big as a skeletal muscle, you're going to have more nuclei. And that's an unusual characteristic of skeletal muscle. Another reason that cell size is limited has to do with, well, commuting or the movement of materials in and out of a cell. So let me ask you this question before we go further. Do you know anybody that commutes every day from Carlinville to Carlinville? Well, I do, kind of. I know other people that live in Carlinville. Maybe you know Dr. Morin, who teaches math. He lives in, and Dr. Boama, both in the math department. They both live in Carlinville and teach a course at Blackburn. Did you ever know of anybody that lived in Carlinville that commuted every day to Springfield? Well, my next door neighbor does that. Do you know anybody that commutes every day to Chicago from Carlinville? Well, for those of you that live closer to Chicago, you know that that would be a heck of a commute. It's about 250 miles to get to Lakeshore Drive from Carlinville. I've driven it often. That might be a 4-hour trip. Well, if you're going to and from, that's an 8-hour day of commuting. So you might think about it and realize, well, if this distance that you're commuting gets too great, then it's not very efficient. And that's why I'm going to guess that nobody knows a person that commutes every day from Carlinville to New York City. That would have to be a very, very fast private jet. I guess that's about the only way you could do it. Well, what does that have to do with cell size? If we take a look at the surface to the deepest part of the cell, the center of the cell, that's the maximum diffusion distance. Gosh, if only we had a term for the distance from the center of a circle to the surface. And I hope you're thinking of the word radius. Yep, so that's the radius. And as we make cells bigger, the radius gets even larger and larger. And so as you make that radius larger and larger, it becomes like the commutes to Chicago and New York City. Oxygen from the outside needs to make its way in, and the center of the cell needs to survive. It needs oxygen too. And CO2, you know, is produced by aerobic metabolism, and so that's got to diffuse out. So to keep the middle part of a cell alive, well, goodness, you're going to have to limit the size, because otherwise it just takes too long to get the oxygen in and the carbon dioxide out. And those are only two of the things that have to move from the surface to the center. At the upper right, we see red blood cells. Red blood cells are very unique. You probably know that they're transporting oxygen. They transport a little bit of carbon dioxide too, mostly oxygen. And here we see that the shape of red blood cells is a biconcave disc, which I believe is an adaptation that helps out with this diffusion distance. So by being flat like that, squeezed in the middle like that, so it's kind of like a donut, but it doesn't have a complete hole, then the maximum diffusion distance is greatly decreased. So there's two limits of cell size.